So the numerical is radio station which broadcast in the long wave region of the electromagnetic spectrum. Long wave region. So do you mean that what do you mean by long wave region? Long wave region means which have a high value of wavelength. And in electromagnetic spectrum, we have lots of other waves. That is, the first wave is the radio wave. Then after radio wave, we have infrared. Then we have that is the visible. Then ultra. Then X-rays. Then gamma rays. Then cosmic rays. Nowadays, scientists also add this rays in electromagnetic spectrum, and that is the cosmic rays. So, sorry, the gamma rays is upper than the X-rays. Okay, so if you go down, okay, this is the electromagnetic spectrum, okay. So if you go down, then your frequency will increase. And your wavelength will decrease because frequency and lambda have an inverse relation. So this is the long wave, okay. So radio wave is the long wave region. If you go down, frequency will increase, but your wavelength will get decreased, okay. So this is the long wave. So long wave like this, your wavelength will have a high value. So this spectrum, this wave have a high value of lambda. Or you can say that long wave spectrum. So these are the long wave spectrum. Of electromagnetic spectrum use carrier frequency. So the carrier frequency which assigned to me, to my radio station, and that is the 140 kilohertz to 280 kilohertz. Okay. So this is the carrier wave which assigned to me. The sidebands are within 4.5 kilohertz. So sidebands are within 4.5 kilohertz. Okay, on either side of the carrier frequency. State the bandwidth of each radio station in the long wave region of the spectrum and calculate the maximum number of radio stations which can transmit in the long wave region. Okay, so let's say this is you can say that this is CTA. Okay, and let's say I will use PTA, that is Pakistan Telecommunication Authority. Yeah, maybe in your country that will be BTA, Bangladesh Telecommunication Authority. So this PTA give frequency range to this city A, and that frequency range is 140 kilohertz to 280 kilohertz. Okay, यानी जो अथॉरिटी है उन्होंने मुझे फ्रीक्वेंसी रेंज दी है और वो फ्रीक्वेंसी रेंज सिटी ए के लिए उन्होंने फ्रीक्वेंसी रेंज दी है. So this frequency range is given to me. Okay, so we need to find the total number of radio stations, that how many radio stations I can build in this city A under this frequency. So I will assign different carrier frequency, and that carrier frequency will be in between these two limits. Okay, sidebands are within 4.5. Hello. So the sideband are within 4.5 kilohertz. आप अभी आई हो या पहले से ही थी जहाँ पे? Yeah,
no, it got disconnected.
Okay, you got disconnected. So I think I need to explain it again.
No, okay. Sir, I did understand.
Okay, so this is city A, okay, and let's say Pakistan Telecommunication Authority is give me this frequency. Okay, this is the minimum frequency, this is the maximum frequency for this city A. Okay, and as an engineer, I will put a radio station in this city A. Okay, so the question is, you need to find the total amount of radio station which you can build in this city A under this frequency, these frequencies, okay, which start from 140 kilohertz and end up at 280 kilohertz, okay, and also bandwidth, and also this the sidebands is given to me, and that is 4.5 kilohertz. So 4.5 kilohertz means that this you must keep your sideband under this frequency, that is 4.5 kilohertz. So it means that the bandwidth, this is the bandwidth, okay? This will be the bandwidth of one radio station. So the bandwidth will be 4.5 kilohertz plus 4.5 kilohertz. So that will be your bandwidth. So your bandwidth will be 4.5 plus 4.5. So that is 9 kilohertz. Okay. So this radio station will have a bandwidth that is 9 kilohertz. Similarly, this radio station will have a bandwidth that is 9 kilohertz. And similarly, this radio station. And go on. So all radio station will have 9 kilohertz bandwidth. Now we need to find the total number of radio stations which we can build up under this frequency. So this frequency is 140 kilohertz minus 280 kilohertz, 140 kilohertz to 280 kilohertz. So the frequency which assigned to me, that will be 280 minus 140. So that is equal to 0, 4, 1. So 140 kilohertz frequency is assigned to me. So 280 minus 140 is, yes, that is 14. Yes, that is 140 kilohertz. So 140 kilohertz divided by 9 kilohertz. So that will give me the total amount of radio station which I can build up under this frequency. So 140 kilohertz divided by 9 kilohertz. So 140 divided by 9. 140 divided by 9. So that is equal to 15.55. So it means that I can build up to how many radio stations? 15 or 16? Zoya?
Sorry?
How many? If I divide 140 divided by 9, so that's come 15.55. So this is the total amount of radio stations which I can build up under this frequency. Okay, so that is 15.55. So that should be 15 or 16.
15.
That should be 15. Why? Because this is in maths we study this, that if the digit after this point is 5 or greater than 5, then you will increment this number. So it is 5. So isn't it will be 16? What do you think?
No, 15.
No, if this is 15.4, okay, so according to math, then it will be right. Yeah, that should be 15. If this is like 15.46, then you can round up it up to 15, okay, because this digit is less than 5. But if you have number like this 15.5 or 15.6, if this last digit is greater than 5 or equal to 5, then you will increment this. Maths tell us this, that you will increment this, so this will become 16. But here this is 15.55. So 0.55, so 15 radio station will build up, okay, not 16.
Yes.
क्योंकि हाफ रेडियो स्टेशन आप बुल्ड अप नहीं कर सकती, दिस इज हाफ, ओके, सो इससे नहीं हो सकता कि आप हाफ ही रेडियो स्टेशन बुल्ड अप कर लें, ओके, सो 15 रेडियो स्टेशन यू कैन बुल्ड अप, ओके, so the total radio station will be up to 15, okay. So 140 kilohertz is the lower limit. So let's say this is my first radio station. So 140, so I will assign frequency this to 140 kilohertz. To bandwidth will be 9 kilohertz. So 140 plus 9, that is 149. So the lowest frequency for radio station 1 is the 140 kilohertz and highest frequency is 149 kilohertz. Okay. Now let's assign radio station frequency. So there should be 149 up to, this is 149 up to 140, from 140 to 149 this radio station will use. Now this radio station will use this radio station will use 149 to hello. Okay, so from this is the lower frequency. Okay, so lowest frequency 140 kilohertz to 149 kilohertz I will assign to this radio station. Then 150 kilohertz to 159 kilohertz I will assign to radio station 2. And similarly 160 kilohertz to 169 kilohertz I will assign to radio station 2. Then similarly 170 to 179 radio station I will assign to radio station 4. Then if you go on, and in the last radio station I will assign one last radio station will be like 270 to 279 kilohertz, or 280 kilo, yeah, 279 kilohertz. Okay, so this will be your 15th radio station. Okay, so your lowest frequency is 140 kilohertz, then your highest frequency will end up on 15th radio station. Do you get it?
Yes.
Or I explain it again. Think about this problem and ask any question. If you have any confusion at any stage, you can ask.
No, sir, I did this.
Okay, so suppose a country decides to increase the quality of music transmitted by each radio station. What happened to the bandwidth and the maximum number? Okay, so if you increase the bandwidth, then the number of radio stations will get decreased, because number of radio stations, you can see that number of radio stations have an inverse relation with bandwidth. So if you increase the bandwidth, then the number of radio stations will get decreased. Okay, like if this is the lowest frequency and this is the highest frequency, and let's say this is the bandwidth. Okay, lowest, this frequency to this frequency, so this is the bandwidth. So one radio station, then second radio station, third radio station, 4, 5, 6, 7, and 8. But if you increase the bandwidth, then the number of radio stations will get decreased. Then this radio station, this bandwidth will increase up to this, then this. So now the number of radio stations is 1, 2, 3, 4, 5. Okay. So now we have 5 instead of 8. Okay, so if you increase the bandwidth, then the number of radio stations will get increased. But if you want to increase the quality, then for increasing the quality, you should increase the bandwidth. Bandwidth is just like the road. If your road is thinner, like this is the bed of your road, okay, then the drivers will feel harder. Okay, the driver को मुश्किल पेश आ गया, rush ज़्यादा होगा. But if your road is wide like this, then easy होगा. Okay, so you can say that the quality will be good. So suppose I can decide to increase the quality. So for increasing the quality, you should increase the bandwidth. What happened to the bandwidth? So bandwidth will increase and the maximum number of radio station will get decreased. Okay, so radio station will get decreased. Okay, last time I also did this topic comparing AM and FM transmission. Okay, so question is, show the frequency spectrum of the signal from a radio transmitter, a carrier, and 2 sideband frequency are present. So part A is, what is the name of the type of modulation that produces 2 sideband frequencies? So what type of modulation is this?
Sorry, so what?
So the first part, so the answer of the first part will be, what is the name of the type of modulation? So frequency, different frequency is given to you. Okay, this is the sideband.
Frequency modulation.
Yeah, so this will be frequency modulation because different frequency is given to you. Okay, so these are the sidebands. So this will be your FC. This is your FC. This will be your FC plus FM, and this will be your FC minus FM. Okay, these are the sidebands, and this will be the bandwidth. Okay, highest and lowest frequency. Okay, and this is the curve of one radio station. Okay, one radio station will have this curve. So this will be the frequency modulation. But what is the carrier frequency? So carrier frequency will be 40 kilohertz. What is the frequency of the signal used to modulate the carrier wave? Okay. So इसको हम किस तरह फाइंड करेंगे? आपके माइंड में क्या आ रहा है? What is the? It means their frequency of, not the frequency. Okay, in frequency modulation we have two frequencies. One is the carrier frequency, and another one is the modulated signal frequency. Modulated signal or informative signal frequency, and that is represented by FM. So इसका आंसर हम किस तरह फाइंड कर सकते हैं?
By doing 1 by t.
By doing? By doing what? Zoya, by doing what?
I thought it will be possible by doing 1 by t, but t is not given.
Yeah, so frequency is 1 by t, but t is not given. So is there any alternate way through which we can find the frequency of the signal, the frequency of the informative signal, the modulated signal?
I don't know.
Okay, so I am giving you hints. Let's say this is FC, okay, and this is FC plus FM, and this is FC minus FM. So hopefully now you can find it. And the frequency of the signal means FM.
I did not understand.
Okay, so FC plus FM, that is the sideband. Okay, FC plus FM is given to you, that is 45 kilohertz. FC is given to you, that is 40 kilohertz, and FC minus FM is given to you, that is 35 kilohertz. Okay, and the question is, what is the frequency of the signal used to modulate the carrier wave? It means that what is the frequency of signal means that this is the carrier wave, okay, and this is my information. Okay, this is my voice which I want to send. So I will place my this voice on this wave, on this carrier wave. Okay, so now this has a frequency that is FM. Carrier wave has a specific frequency that is FC. But when I place my voice on carrier wave, then I have two frequencies. Then this signal will have two frequencies. One is the FC, another one is the FM. So FC is given to you, that is 40 kilohertz. FM. So the question is, you need to find the FM. But sideband is also given to you, and that is 45 kilohertz, that is 35 kilohertz. So you need to find FM. अच्छा मैं आपने O-level में मैथ्स पढ़ा था क्या? Okay, so FC plus FM is given to me, that is 45. So this will be FC plus FM, that is 45 kilohertz. Okay, and FC is also given to me, that is 40 kilohertz. So instead of FC, I will write 40 kilohertz plus FM, and that is equal to 45 kilohertz. So my FM will be 45 kilohertz minus 40 kilohertz, that is 5 kilohertz. So this will be my final answer. Okay. And you can also find it like Fc minus Fm, that is F35. So from this you can find this answer of this part. Okay, what is the bandwidth of the transmitted signal? So bandwidth, so this is the bandwidth. So bandwidth हम यहाँ पे किस तरह find करेंगे?
2 FM.
जी.
We can find it by 2 FM.
Yeah, 2 FM. Good. Yeah, that is 2 FM. Yeah, you can say that highest frequency minus lowest frequency. So you can say that 45 minus 35, so that is equal to 10 kilohertz. Or you can find at 2 FM, that is 2 times FM is 5 kilohertz, so that is 10 kilohertz. Okay. Okay, pardon.